My name is Mike Usrey, and welcome back to Flyin Miata Live. Today, we're going to be talking about 3D printers. So, if you are a 3D printing nerd like myself, rejoice, because we're going to talk about a lot of nerdy specs. But first and foremost, we're going to talk about why are we even talking about 3D printers at all in general. This is something that a lot of people use as a hobby, but we actually use for production purposes. So, before we get into the hows, the whys, the whats, all the nerdy details, I just want to invite everybody that if you have comments or questions, or maybe you're into 3D printing and you want to see something in particular about these printers that we're going to be talking about, put those down in the comments below, because we can try to cover that during this video. So, without further ado, let's talk about printers. We have been printing as a product, actually several products, for quite a while now. At this point, we have, 10 printers that we have in our fleet, which sounds like a lot. At least it seems like a lot, from going from a company that we primarily work with steel or cast ductile iron or silicone and, traditional automotive-based materials if we're building parts for cars. But nowadays, a lot of the stuff that we do is using very complex, very strong, very resilient plastics, because they can be very effective at doing the jobs of what might have been a heavier metal component or a less durable silicone or some other kind of material. And now we can make them in-house. We can do lots of tests and revisions, and we can utilize these machines to basically make better parts that cost less for everyone, including all of our customers. So there's a lot of benefits involved with 3D printing, and I won't go into detail here too much further because there's all kinds of stuff on YouTube if you really want to dive down the rabbit hole. But in short, we've been using printers for a few years now because we can do a lot of these kinds of things, and it helps out everybody. So let's start with a little bit of what we're looking at here currently. And if you'll pan over this way, Travis, these machines, you can see we've got 8 of these kind of light gray machines. They're called Markforged 1 printers. And these have been kind of our mainstay for a long time. We started with 1, we got a couple more, and it just kept growing because we kept needing to print more things. These Markforged printers have been really key for what we've been doing up until this point, and they do a great job and continue to do a great job. They print using a carbon fiber infused nylon. It's a very proprietary special mixture that Markforged does specifically for these units, but we've had lots of success. Now, in 2025, and actually leading up till 2025, we've actually, even with these 8 machines, had a bit of trouble keeping up with our 3D printed tools and pieces, adapters, covers, plates, brackets, you name it, all kinds of things that we produce and sell at Flyin Miata. And we've heard your complaints. Why are you guys out of toolkits? Why are you guys out of, dipstick handles? Whatever. You guys make them in-house, right? Why don't you have these? Yes, we understand. They have been super popular, which is a good thing. It's a good problem to have, but it means that we have to keep up with that demand. So we've had really good success with the Markforged printers, but we thought, hey, what if we can take this even further? Can we get printers that print even faster, even bigger print volumes, more tools per print, or more whatever, prototyping, faster, better, stronger, all of those kinds of, fun things. So that's where we are today. And today, we're going to be talking mostly about these 2 behemoths. So yes, these are 3D printers. They may look comically large compared to those in the background, and that's kind of because they are. These printers are Pantheon HS3 3D printers. We just got these in earlier this week. Kyle has already gotten his drool all over both of them. He's been very excited to get these printers up and going. You can see this second one over here, we've got prints already going. We've done some tests, and we'll talk more about what the tests look like and how they perform differently from the Markforged in just a little bit. But these guys, they're huge. They're almost exactly 2 feet cubed for their outdoor dimensions. They're big guys. But what's really impressive about these is kind of more on the inside. And we'll talk about some of the detailing stuff. I'm sure that if you're a 3D printing nerd like myself, you're already rubbing your mitts together in anticipation. But these guys are very similar to the Markforged printers in that they allow us to continue our productivity with the 3D printed tools and components that we have here, but at a much faster and bigger volume than we could with the Markforged. So these guys are basically taking everything leveled up another few notches. The key components for what we're looking at here is that these machines actually just, you can probably see, this guy, the print head is just absolutely flying around. Now this isn't even its fastest speed or anything like that, but it is insanely quick. These printers will print their standard printing up to 500 millimeters per second for how quick they move that nozzle while it's still printing. Generally, a continuous print movement is not usually up to 500 millimeters per second. That's its max speed. Most of the time when we're seeing stuff happening right now, it's going to fluctuate anywhere from, basically standing still when it changes directions up to maybe 200 or so millimeters per second. It just depends on where it's going, how it's moving. It's really quick. Unfortunately, I don't have a number to compare that speed versus the Markforged because they don't list their specs publicly, which is a little bit of a bummer. And I'm not saying that these are bad printers or anything like that because of the speeds, but just to give you a visual example, why don't you come take a look at this guy. So this one is printing out, looks like maybe one of our eyeball vents, I believe. Oh, is it a brake duct? I'm sorry. Oh, that's right. So this is the same thing as the print that's over here that we were just looking at. But you can see, you can see that it is printing and moving pretty slowly compared to the other one. But this is exactly the same print, or at least the same object that we're printing over there on the new Pantheon. These guys do a great job. The print quality is phenomenal. We had really, really good luck with these. Is that clear enough, or do you want me to open it up? You can see? Okay, cool. But yeah, the print quality is great, and no complaints as far as the end product. They turn out excellent. But the speeds and the print volume are just not as good, at least not comparatively speaking to these guys. But speed-wise, that's what we're up against. These guys absolutely jump from point to point. They move around really, really quickly. They're very efficient. The other big thing I just mentioned is volume. So these guys, the beds, you kind of look at them and you're like, yeah, it's square. It's different from the Markforged one. It doesn't look like it's that much bigger. But let me give you some examples of what it looks like in application, because over here I actually have the print beds for both printers. So this one is the Markforged print bed, and this one is for the Pantheon. And you're like, okay, one's rectangle, one's square, whatever. That's not the full story. So one of the things you have to take into account when you're talking about 3D printers is the print bed volume. So not every printer, most printers actually, can't print all the way out to the edge of the beds. There's always got to be a little bit of kind of a margin of error. So just to compare, what I've done is I've actually used some tape here to showcase how much area you actually get out of this bed. And this one is these are all metric, 320 by 132 by 154. And I will specify that this is the height. So 320 by 154 is your width and depth on this plate. So everything within this blue tape, that's the actual print bed volume, or the area. Now comparing that to the Pantheon plate, which I've done the same thing, this is 300 by 300 for the area. And this one, you can see, it's not quite as wide, 20 millimeters narrower, but otherwise it's very nearly double the area of the Markforged printer bed. And then of course this middle number for height, this one is, what is that, 2/5 or so the height available to the Markforged versus the Pantheon. So when we're talking area, that's nearly twice the area, and about, actually I think it's like 4.14 times the volume of what the Markforged can print. So we have a lot more real estate, in short, how much we can print, what size objects we can print. A lot of the stuff we print is usually going to be smaller components, brackets, things like this, things that really make sense to print in plastic. But if we're doing something that needs to have a larger piece that will eventually be made into a billet bracket or something like that, that we want to make it in something stronger. Maybe we're going to do a prototype for one of our turbo manifolds or something like that. We really wouldn't have much room to do that on these smaller plates, whereas with the larger plates, if we need to do some prototyping, we have a lot more capacity to do that before we get to the point where we need to start printing halves and gluing them together or something like that. So this gives us a lot more productivity and a lot more room for prototyping, which is great. That means that we can do everything just that much quicker and simpler. So build speed and volume have a huge increase on these machines, these new Pantheon machines, compared to the Mark Forged. Now, there is a little bit of an unfair comparison going on here, if you haven't been able to tell. The Mark Forged 1 printers are actually a discontinued printer at this point. They are basically, you could say, last gen printers. They have new stuff now. They have, I think they call them the Mark Forged Onyx, I think is the new model. But these guys, of course, are the current generation of Pantheon, which is another reason why they're such a big step forward in all of the different, easy, big, fat numbers, speed and volume and all that kind of stuff. But let's talk about some of the little things that just make these a nicer machine to work with in general for us, other than the obvious. I don't know if you can hear it through my microphones from here, but the Mark Forged printers, you can hear the belts tightening and stretching, and you can kind of hear everything moving around and creaking. Hopefully that's picking up on the microphone. So not bad, for a 3D printer, they're not bad, actually. I've heard much noisier, but you can hear all that noise, and especially when there's 8 of them going, oh, this room is pretty noisy. These printers over here, this one, even though it's just absolutely blasting through this print, I can hear a little bit of movement just from the bearings and stuff and the motors, but especially with these lids closed, I can talk normally next to it, and it's totally comfortable. So the amount of noise that is captured and kept retained within these boxes is really impressive. The other kind of impressive thing, since everything's shown off in these cases, is of course all of the motors, all of the screws, all of the gantry work that's in here. These boxes and all of the machinery and construction on these is super beefy, kind of overbuilt beefy. We actually had to bring in a really big table, and Kyle reinforced the back of it and the sides of it, because the amount of force as the heads of these print machines are moving around is so great, it would shake every other table just like a rag doll. And even this one will move around a little bit, even though it is sturdy. This is probably a 150-pound table at this point. But these guys are super beefy, really overbuilt, which is great because that means that product stability and all of your testing comes out very repeatable. Everything is not getting knocked around or uncalibrated because things are flexing. This build plate actually here, this is a 16 millimeter thick build plate, and it has to be thick because it is a heated build plate. It's actually heated up to 500 watts. So to keep it from having issues with warping or anything like that, everything is just beefy on this unit. Speaking of beefy, the motors, if you're wondering about these motors, these are all stepper motors, which is pretty common for printers, of course. They are very strong. These two that control this axis, and then the one here at the back that controls this axis, all of your XY movement, those 3 motors combined equal a horsepower. 1 horsepower out of those 3 motors, which in a printer is pretty insane. They have really, really precise movement. Everything is on these tracks, these rails. And of course, being that it's a screw driven with like nice, really smooth bearings and all that kind of stuff, there is no problems with it absolutely whipping around at those high speeds with those really powerful motors. The other reason that these are such big behemoths of units is that these boxes also serve the purpose of not only just supporting the structure, making sure everything is stiff, but they're kind of acting as if it's an insulating box, almost like an oven. So when I mentioned that this plate is so thick because it heats up to 500 or using 500 watts to basically warm up the plate itself, you don't keep it at 500 watts worth of power to keep the plate warm by itself. It's actually going to do that to preheat the entire box like an oven. So that way, as your print is continuing along its path, then all of the material can stay at a consistent temperature or as consistent as possible. And you can also kind of see, maybe in this one, since the lights are on, it has all of this reflective material that is insulation in there. Same kind of thing. It's just helping it give a more consistent temperature throughout. Let's see. Do we have any? We do have some. Oh, good. We have some comments. Okay. What do we have so far? I'll stop here. I can chatter for a while.
Can FM do custom print jobs?
Ah, okay. So this is a good question. We get this quite often. The question, one of these questions was, can we do custom print jobs for customers or, friends or whatever the case is? Short answer, no. We don't do custom print jobs because once Kyle gets these finely tuned and they're up and going, these machines are basically going to be running 24/7 for us. Not quite, that's kind of an exaggeration, but basically as often as we can, and especially since we are trying to work through the backlog of getting caught up on the tools and the prints that we haven't been able to keep in stock, we have to keep these machines rolling for production purposes. Now, we don't use these much for prototyping, except for sometimes in-house we might try like a bracket, if we might be designing a bracket to do for an upcoming kit or something like that. But as far as like, if you want to try something out and you want us to print something out of material that we have here, unfortunately, no. These machines are just going all the time trying to keep up with demand. That's really, that's the short answer of why we're doing this video, talking about why we got these printers. We are trying to up productivity and efficiency. So by doing these printers or using these printers, that's essentially what we're doing, is trying to catch up. Between the build volume and the speed of these units, they go so quickly. And actually, that's a good segue into what's happening right now, where this print is getting finished up. That this print took about 2 hours and 15 minutes, or a little less, I think. A little less than 2 hours and 15 minutes. This is a brake duct, effectively the same thing as this guy right here. So this guy printing, and it's, wrapping up just the very, very top of right here. And it's going to be done probably any minute now. Yeah. Oh, it's done, literally right now. That's awesome. Took a little over 2 hours, and it's all finished up. Now this guy, we started this print at the exact same time as this one right here. That's the same part. And this one, the scheduling is about 8 hours for the print on this. Again, quality is great, no complaints, but speed and efficiency is always going to be something to continually improve, make better, gets us products faster, makes us able to fulfill orders faster, all of that kind of stuff. So when we're shopping for printers, these guys came up, we're like, oh man, these are looking pretty shiny. And so far, we're really happy with it. The other thing that I should talk about besides that, actually, while we're here standing next to them, is that these printers, they both have their own boxes, of course, but they give us more options for printing. The Markforged, we can only use their Onyx material, which is a carbon fiber reinforced nylon. It's good stuff. But alongside carbon fiber reinforced nylon, that's actually in this guy, on this machine, we're actually using a carbon fiber reinforced PETG, or PETG. So they have a wider, and there's other materials we can print too, but there's a wider array of materials that we can print with these machines that we couldn't print with those machines. So gives us more options and potentially more applications that we could use for different tools, different pieces, different adapters, depending on the plastic that might suit that situation best. Okay, we got more questions. What do we have?
I love 3D printing, but the printing lines make the part look cheap. Are there any suggestions on what we can do to make the print look more like a high-end part?
Oh, okay. Yeah. So this is another concern that we actually hear about a lot. Let me show you an example. The question was talking about if you can see print lines and, making it look professional versus hobby level. So one of the other things I wanted to showcase is that I actually brought in, this is what, if you're a 3D printing nerd, you would recognize as a benchy. It's just a little model of a boat, and it's just something that a lot of 3D printing people will use as kind of a gauge whether their machine is calibrated and set up properly. And this one I printed on my own hobby printer that I just got. So this one is it's PLA, so it's a different kind of plastic. And I won't get into this plastic versus that plastic for texture and how that affects. That's a whole nother ball of wax. But you can see, hopefully on this one, that there's some stair stepping here kind of on the side, and you can see those lines, those print lines. And this is on a reasonably good hobby machine. You know, nothing fancy, but it's definitely something that you can tell that's obvious. And you can tune this out to some extent. But to give you an idea of what you can achieve with professional, like industrial level machines like these guys, is let's do these actually. These are two of the same piece. Make sure I can get the right light here. And here in my left hand, this guy was printed on the Mark Forged units. And you can, sorry, I'm moving stuff around. You can see the lines a little bit, but for the most part, it almost looks like it's a uniform texture. This is the Onyx carbon fiber infused nylon material, and it's not perfect, but it's pretty darn good for 3D print. So you will almost always have a little bit of texture or, you know, telltale signs that it's printed. But oftentimes, if you have the print settings dialed in and you're using good quality material and good printers, you can almost get that to go away. Actually, you can kind of, just right here, this section is really smooth, kind of difficult to tell that it wasn't like an injection mold with a texture. So that's Mark Forged. On the right here, to showcase this one, this is off of our new Pantheon printer. And it is a slightly different look to it. It's a bit shinier, but that's because this is the PETG carbon fiber rather than the nylon. It just has a little bit more gloss to it. But this one you can see, it's also very difficult to tell. The texture, especially with that little bit of gloss to it, makes it a little bit more difficult to tell the layer lines. Hopefully it shows up on camera. I know that can be kind of difficult. But this guy, it just has much, you know, they can have really, really smooth textures, and we do try to get a nice smooth finish as much as possible. There are, if you might have seen these earlier, we did a video talking about our roll bar covers and how they did have facets and it was kind of polygon looking, and we did end up actually changing the listing to address that and discounting them because it had settings applied to it that just needed to be smoothed out in software. It's not a problem necessarily with the printer, because here's an example of what they can look like all nice and smoothed out. This one was a relatively quick print, just a proof of concept, but you can see that there are no more of those triangle polygon kind of shapes in the side of it. You can see a little bit of that kind of layered texture to it. But again, a lot of this kind of stuff can be smoothed reasonably within the software to be able to make it a nice finished product that doesn't look like it was, you know, off of somebody's hobby printer that cost 150 bucks. So hopefully that will, these examples will give you a good idea of, you know, what these printers are capable of. We're not printing stuff at a hobby level. We do have engineers that this is actually part of their full-time job, is to maintain, utilize, and really dial in these printers. So print texture and how it appears is always a good thing to be able to refine, especially with high-end units like this. Yes?
Still got a couple more.
Okay.
Mike, what is your favorite part to print?
What is my favorite part to print? I will say that at the moment, because I'm really new to 3D printers myself, like my hobby printer that just came in, literally just came in. I printed that green little benchy last night. That was my first print on that machine. I can't really take full credit for this because this is Kyle's baby. He's standing behind the camera. But these are his printers more or less, as far as he's the one who takes care of them and does all the printing. What I will say, as far as the kind of prints that I like, that we do, I wonder if we have an example here. We have everything kind of quiet right now, so that way we could showcase the two printers in action. I don't think we have it here. One of the things, I'll use these guys because of the example. Any of our products that have text in it, I like that these printers do such a super job of the definition and detail for things that you kind of take for granted on a 3D printed part. If you've ever 3D printed lettering or stuff that's inset or recessed like this, it can be really difficult, but just the level of detail that these printers do, it just looks phenomenal. I'm super happy with them. So, favorite print, out of design, I don't know, that's a tough one. I don't know if I have a favorite, I'm sorry. They're all super cool. I nerd out about all of them. Yes?
Are we willing to share how much these machines cost?
Are we willing to share how much they cost? Well, these machines cost us a different amount than they would for most people who went out and shopped for them right now. That's a very vague way to say that we worked with Pantheon directly because we wanted to buy multiple. So we got a different price than if somebody just went on their website and clicked buy. These machines, I think the starting price is $99.99 US dollars, if I recall. Yeah. So essentially, at least market, street price, if you wanted to just look at it that way, this is essentially 20 grand of machine sitting here on this table. Not what we paid, but that's what these guys are normally worth if you're just buying one for an individual. Yes?
How much manual versus automated calibration do these need?
Oh, how much automated versus manual calibration did these require? So that I don't know. Kyle, would you like to enlighten us?
Well, there's not a lot of calibration that needs to happen.
They won't be able to hear you unless you stand over here next to me.
Okay.
Everybody, welcome Kyle. Woo!
I knew this day would come. I've been avoiding doing the FM lives, but here I am.
So hopefully you can hear all right. You'll have to speak loudly.
Okay. Well, as far as calibration, they're fairly well set up out of the box. And when you start a print, it actually will do a 100-point bed leveling. So you'll see the print head go and hit 100 different points, a 10 by 10 grid. And it'll map out the bed and automatically level according to that. So it's super easy. It's basically set it and forget it.
It's really fun to watch the calibration because the print nozzle hovers at kind of a 0 point, and then the bed will just go up and just bonk the nozzle, and it has a pressure sensor, so that way it knows when the bed touches the nozzle, and then it'll move the nozzle over and bump it some more, and it moves it around those 100 different spots on the bed.
It's a little disconcerting because it makes a little bit of a thunk.
Yeah.
And you're like, oh, that doesn't sound right, but that's what it needs to do.
Yeah. So, but basically that and you're done. There wasn't really any other calibration setup that we needed for these?
No, out of the box, they plug it in and good to go.
Yeah. And as I understand it, basically like the different materials that we can print with, as long as they come from Pantheon, they already have calibration files set up within the software. So that way, if you tell it, print this thing, I'm using your PETG carbon fiber or your nylon carbon fiber or whatever,
Yep.
that they have already dialed in all of the settings to know what extrusion speed, what nozzle speed, all of that kind of stuff. So that way it basically takes all of the guesswork out of the equation. You just tell it this stuff, press print, and it pops out pretty much perfect, or, with a little bit of tweaking on our end if we need to the model. But that's kind of it.
Yeah, I mean, there's probably hundreds of different settings I can change, but if someone's already done the homework and got it set up to be optimized for that material, I'm not going to spend a lot of time messing with that. I'm going to cheat off the guy who got the A on the test.
Yes, it's in the business world, that's usually a good idea anyway.
Yep.
Especially when it comes to tweaking, dialing, setting, all that kind of stuff.
Oh, yeah.
Yeah, cool. Okay, do we have other questions beyond that? Okay, Kyle, thank you. Appreciate
Okay.
it. I'll let you go now.
All right.
What layer height do you print
What layer height? Oh, excellent question. Okay, so it depends on the product. In particular, like this guy over here. Kyle, is it okay if I pull this off the bed?
Yeah, you're good.
Okay, so since this is a fresh print and you saw it actually in process, I'll flex it a little bit. There we go. Boop. So brand new, fresh print. And so you can see the layer quality. This was printed at a 0.2 millimeter layer height. And we can, of course, adjust that, if we want to do a more fine layer look to it, which basically is one of the ways that you can change the texture or look of the piece. But this is 0.2 millimeter. I think normally on the Mark Forged, that's where we would print either 0.1 or 0.2 millimeter right there in that ballpark, depending on the product. That way we maintain a pretty high finish texture. What else do we have?
Printing nylon is generally known as a health concern to be around. What kind of air scrubbing / safety protocols are involved?
Oh, great question. So yeah, talking about printing nylon and being a health concern. So direct your attention to the back of the machine, maybe probably from this angle, Travis, or that one. Yeah, perfect. You can see that there is a fan, a dual fan set up, at least there in the top. And behind those fans, there's also a filter. I assume it's a HEPA filter.
I believe it is a HEPA.
Yep. And that filter actually is what is essentially keeping us from getting sick and nylon fume poisoning or whatever you might call it. But yeah, these guys, because they are contained units, they are intended for use specifically with nylon printing to prevent that from being a problem. So easy peasy, or at least Pantheon made it easy for us. Good question. What else?
What does one of those new machines weigh?
Oh, what did the new machines weigh? Kyle, do you know?
They are 143 pounds.
143 pounds.
Each.
Each. Yeah.
And I had to get them up the stairs.
Yeah, and Kyle says he had to huff them up the stairs one at a time, or actually maybe a few parts at a time, I suppose.
No, as an
Did you-
assembly, 2 people.
Oh, so Kyle's real tough. He actually just had somebody else help him get the whole thing up the stairs. And I will point out, since we're talking about the weight, one of the reasons why they are so beefy because of the over construction, or I guess thick construction. Talked about the bed plate, but actually like this piece of black metal, this whole upper plate, this is all billet T6061 or T661. Oh, I'm messing this up. T66061. I'll just say 6061 aluminum because that. You guys will know what that means. Most of you are probably smarter than me when it comes to alloys anyway. But it's all billet aluminum, this whole plate. And this is like a 20 millimeter thick plate all the way around, of course, with the hole in the middle to allow the bed to come up for the print head to access. But these things are solid. The rods here for the Z-axis, I'm pretty sure these are solid rods. So they don't move, they don't wiggle. The Z-axis is very secure. So yeah, the construction of these guys is just incredibly beefy. So yeah, 143 pounds per. What else do we have?
Do the printers require much maintenance?
Oh, another good question. Do the printers require much maintenance? Kyle, I'll probably have to ask you to come back on this one because I don't know this one, unfortunately.
Well, I guess I'll come back on. I too do not have it committed to memory. I just printed off the spec sheet. But there's going to be nozzle replacements every so many kilograms or so many spools. There will be hot end replacements every so many kilograms or so many spools. Greasing the screw tracks, and that's all that I'm remembering from seeing on that spec sheet. But yeah, there is a maintenance list.
Yeah, these are tools. Tools do wear out over time. They do require some maintenance. From what I gather from my very limited research on these guys, it seems like it's relatively minimal. You know, the other things that maybe he didn't mention specifically, but just general to 3D printing, is that these tubes where the material travels through, These are just flexible tubes here, and it connects to the material, which you can see coming out of the box here. As the material travels through these tubes, that material does wear on the inside of the tubes, gums things up, it gets dirty, or literally wears holes in the tubes if you let it go too long. But you know, stuff like that, moving parts, everything does wear down over time, and there are replacements. And fortunately, most of that kind of stuff is either universal, or it's stuff that, like, actually, in the case of these supports, these are 3D printed. So if we needed to replace these guys, we can literally print our own replacements. There's a lot of components like that on these machines that are actually 3D printed. Like there's a fan shroud around the back here that's 3D printed. These handles, like say we were careless and you know somebody walked by and just banged that handle and broke it off, we could literally just print another handle. You know, these hinges, these latches, even these little stoppers, they're all 3D printed. Now, not everything's 3D printed, but that's kind of another one of the beautiful things about 3D printers is if you need a part, you have a part maker right here. You can replace a lot of stuff if you can't buy it commercially, like tubing and fittings, metal stuff. What other questions do we have? Is that covering it? Okay. The one thing I didn't show you that I was going to, Kyle, do we have that other hot end? Or did you move it?
Hot end is going to be down here.
Oh, okay, gotcha, sorry. I just wanted to show this off. I thought this was really cool.
And spool size.
Oh, that's right, yeah, thank you.
I'll get you a mark on
Perfect, thank you. So I wanted to show this off just because these are really neat. This is the business end of a 3D printer, specifically one of the Pantheon printers. This is what is referred to as the hot end. And essentially, you have your material that's forced down through the top of this guy and into the heating element portion. Then you have the extruding nozzle here, which, by the way, on this printer is a 0.4 millimeter nozzle. Probably can't even hardly see the opening there. But these guys are special in that, one, they are special to Pantheon, but also because they have so many wires. Normally, you'd see, you'd have a temperature probe wire, and then you'd have one set of wires like this. This is the heater. So there are heaters in this nozzle. A lot of printers only have one, but this one has two. And that's how it's able to heat up the material so quickly and so effectively. You can actually tell these nozzles to heat up as, I think it's as high, what did I write down, 500?
500.
Yeah, 500 degrees Celsius, which is insane. I don't know of any material that actually needs to be that hot. Even like carbon fiber nylon, you typically heat up to like 300, maybe 320 degrees C. So being able to go to 500 is almost, it's just unnecessary for anything we're going to do. But that means that these can heat up really quickly. So if you need to start getting the machine going, it doesn't take as long because these guys just, they are on and heated up to full temp in like a minute. Really cool. The other cool thing, thank you, Kyle, that I wanted to show off is the material. So here, almost all spools are going to show up in some kind of a vacuum kind of wrap, plastic foil something. This is a 1 kilogram spool of material for the Mark Forge printers. And this is pretty standard. A lot of hobby printers will come with like 1 kilogram or maybe, you know, small amounts of spools this size. And this is pretty typical. The spools that we use for the Pantheon printers is a 3 kilogram spool. Larger diameter spool, just, I mean, literally 3 times as heavy. That's how kilograms work. But they are huge. And these boxes, you can kind of see what it looks like, of course, when they're in there. But this allows us to let these printers go for longer without having to change out material as often, which is just another one of those efficiency things that we like to be able to kind of work in our favor because of these machines compared to the Mark Forge machines. So just another cool thing. Any other questions? It's popped up? No? Okay. I think that pretty much covers my notes. Kyle, did you have anything else in particular?
No, I think you got it all.
Cool. I'm sure there's a lot more to talk about. Again, just wanted to just show these guys off. I think they are really, really cool. we are really excited to actually get them going and hopefully bring all of our production up to a point where we just don't have to worry about back orders for our 3D printed components going forward. That's the plan anyway. So I do want to note that these products, such as these ducts for an NA, for brake ducts off the front lip of a car, these are part of a U-Design program that we have. So if you have products like this that you're like, I really like this, I made this thing for my car, and I think that a lot of people would enjoy these products too, we actually have this program called U-Design. And what it means is that you can submit your STL files or object files or whatever you've got through this program to Flyin Miata. We'll take a look at them, and if it's something that we agree, like, yeah, that looks great, I think we can sell that, that looks like a great product, then we will make these as part of our U-Design program, and then for every unit that we sell, you earn a royalty for it. So if this is something that maybe you do design in your free time as a hobby, or maybe you're a professional that you design components for airplanes or fridges or whatever else that's not a Miata, but you want to do some fun Miata stuff, maybe submit your design on our U-Design program page, and we'll see where it goes. If it's cool, it might end up on our product store, just like this. We will leave a link down in the comments below for the U-Design page if you'd like to go check it out. Otherwise, I think that is it for now. So I will stop yammering about 3D printers. Of course, if you have more questions about this, feel free to call us, email us. You can get a hold of us, and we'll talk to you about all kinds of nerdy stuff that we're all about for new products and new things at Flyin Miata. In the meantime, I really appreciate you watching this video. If you liked it, give it a like. Of course, subscribe if you want to see more videos like this, and hopefully we'll see you again next week, same time, same place. Thanks again, everybody. Have a great one.